Hello and welcome to MSUA Game Changers Live, where we speak with satellite and mobile connectivity thought leaders about industry trends and share what you need to know about the future of mobile satellite communications. I'm your host, Roger Lanto, and I'm excited to introduce Steve Gizinski, Chief Technical Officer for Viasat Government, where he manages the technical innovation of the Viasat Government suite of SATCOM solutions for government missions, both in the US and across the world. He leads and oversees the delivery of customized, secure communications capabilities across maritime, aero, land, cyber, and space domains, addressing the critical connectivity needs of government partners worldwide. Steve has over 30 years of leadership and in-depth experience overseeing mission-critical technology efforts for commercial intelligence and U.S. Department of Defense clients. He has held various management positions at Northrop Grumman, Hughes Space and Communications, Lockheed Martin, and as a fellow in the National Reconnaissance Office Technology Fellowship Program. Steve's here to talk about Viasat's InCommand solution, which won the Government Mobile Innovation Award during MSUA's Satellite Mobile Innovation Awards earlier this year. The InCommand solution enables command and telemetry on demand for space assets operating below geostationary orbit by establishing real-time connectivity for space relay in support of low and medium Earth orbit satellites. InCommand delivers an efficient, cost-effective, and time-critical solution for any low Earth orbit satellite by removing dependencies on ground infrastructure. Welcome, Steve.
Thanks, Roger. That was a whole lot. I think you've done the whole presentation, so thank you.
Yeah, let's wrap it up. Okay, so Viasat got this award. Tell us a little bit more about this solution that earned Viasat these accolades.
Yeah, you bet. So it's obviously our desire to always continually innovate at Viasat. And again, we're legacy Inmarsat now merged together with Viasat. That's where things started with InCommand. But the focus always is on how to figure out how to do things better tomorrow than you did yesterday. And so in this case, we've been doing ISL, inter-satellite link services for different low Earth orbiting satellites with a product called Viasat, something that DARPA funded us circa 2010 to get implemented. And we realized there was a need for improvements. And so in this case, both just by general market pressure, as well as NASA's communication services project, the need to replace MA solutions that are on TDRS, it became clear that there was a need in the market for us to build something different and improved over what we had been doing, since that 2010 timeframe.
And so what are some of the most important benefits and features of this solution that really makes it stand out?
Yeah, what we enjoy about the satellite connectivity from what we can provide to a LEO operator is that opportunity for real-time access to a satellite constellation. And most often this is used either to get an understanding of the health and status of the network in real time, which can be critical, right, to maintain resources on orbit. But more commonly, the ability to connect with and task a satellite in real time, to be able to make adjustments to its tasking deck, or to get tip-off from a spacecraft that has seen something and has some processing capability, and then the network and the collection process benefits by having those insights made available, in real time. And our sense is the most common architecture would be, a ground gateway that the command and control function lands at, and the mission data lands at, and that ground gateway maybe is only visible at certain points in time and certain points of the orbit. And the benefit here is with the geo satellites being kind of at their perch at the geo orbital altitude, they're able to see the LEOs underneath them and connect with them really kind of no matter where they're at in that footprint.
So how long have you been providing the solution, and where are the customers you are supporting with this solution located?
Sure. Yeah. So 2010 is when we began the work with DARPA, and then shortly after, this is for the Viasat capability. And that's been put into use by operators. We're bound by NDA not to share who they are, but they're not just U.S. based. There's U.S. based operators and then global operators. We've got partners that help us, with pieces of the technology that we make use of, which is always good to have kind of an ecosystem in the sense of like selection of terminals and antennas and even landing points just for some sovereign concerns that can be helpful. And so. Yeah, since 2010 is when we kind of began the effort to develop, and then shortly thereafter we were on orbit and operating, and we have been learning and improving since.
Let me ask you a little follow-up on that. Is this a case of commercial applications and solutions and customers benefiting from developments coming out of the government?
I think so. Yeah, I think the the focus that we've got, of course, is to meet kind of a wide range of needs. But the reality is often the government, especially an organization like DARPA, will be first through a very, very difficult problem, and they'll solve it. And then it's good in that case for US DoD, but then the reality is not too long thereafter, others can benefit from that investment.
And can you describe some of the specific customers? I know you don't want to say too much, or maybe you're limited.
Yeah, LEO operators. Yeah, it's hard because we're kind of bound by NDA. But if you could think of folks that would benefit, anybody who's doing kind of remote, science, sensing things, that getting real-time access to their asset that does that sensing, they find value to it. And it's very affordable. And I would have mentioned, NASA with TDRS actually was really kind of one of the original pioneers in this space, with those satellites providing, multiple access service to their collection of satellites that were doing Earth sensing. So it's been, this isn't per se new in some fashion, in the sense that connectivity has been desired and some have been benefiting from it, but it is new in the commercial sense that it's being provided and the rates and services that are available.
And forgive me, but TDRS was new to me, which is tracking and data relay satellites. So what's the status of that sunsetting? Is that gone now, or what?
No, the goal that NASA has expressed in their CSP program is this idea that by 2030, they'd like to have commercial alternatives to the services that TDRS is providing. And so in essence, that's for the award that we got with NASA. It relates to making sure that we fully mature the service, so that anybody who historically has relied on TDRS could now make use of this commercial offering.
Interesting. Okay. So what advancements has this solution made available?
Yeah, I think the real key that we see with our users is just this ability to be able to connect in real time to their platform. And so one item that I mentioned was just this idea, there might be a world event that occurs, and then a desire for some sort of sensing satellite to the event occurs, but my satellite already has a load that says go do this, because that was the baseline mission. But then this world event, perhaps it's an earthquake that occurs somewhere. I really want to immediately be able to get, say EO, electro-optical imagery or SAR imagery of the area, and yet my spacecraft are not in view anymore of the gateway that they normally downlink on. And so in this case, what could happen is they can immediately, take their spacecraft tasking, the operator could take the spacecraft tasking and then modify it so that this new event can be considered, in the collection tasking. The other piece is, and some that we work with are doing this, we do a lot of work in kind of the AI ML area, right? Like, what does all these large sets of data that you've got, what did they tell you? And then what should you do as a result, and continually kind of processing on that data. And so there's even systems that, we work with that have an ability to provide tip-off. And so you might have something that happens and the satellite sees it first, which is common, right? That's one thing that satellites are very effective at. And then it can inform the rest of the system, either to task satellites that are following behind the one that just went over, saying, hey, this occurred and you should pay attention, or even perhaps cue ground elements for mission data to be prepared and prefer the things that relate to that event that's occurred. So our sense is you get both of those, right? The spacecraft can either be retasked or it can provide tip-off. That's helpful to make the system be much more efficient in what it does.
It's funny. I come from the world of connected cars, and cars are definitely not communicating enough. And I don't think people understand how much satellites are communicating between each other. And this is obviously a part of that. How do you expect this service and solution to change over time?
Yeah, we continue to invest in these sorts of things because, of course, we're believers in what satellites can do. So what I would expect, like when we did SBSat, that was based on the Inmarsat BGAN waveform, it's Broadband Global Area Network. And what we discovered is that worked for many, but it didn't work for everybody. And in particular, there was a community of users that used CCSDS-based solutions, which is a very important standard for space data systems. And so even InCommand, like what we first did was just introduce a CCSDS compliant path for folks that felt that was better than something that was different. And it's not like both work, but they're if you've got all this infrastructure and software that's already written in place, it's much easier to stay compliant with your standard than it is to go to a new standard. So we see that, but then the next step would be, of course, different ConOps and scenarios for sensing that leverage this idea that I'm real-time connected, right? This is continuing to evolve. AI on board a spacecraft to detect things with that real-time pipe. So we see that kind of evolution, as well as, again, being able to more efficiently task, right? If I've got a set of resources that are doing collection, I want them engaged in meaningful collection always, not in just filler. And so I see that occurring. And then relative to our solutions, we operate in L-band with InCommand. That's around the 1.5, 1.6 gigahertz. And right now it's at a certain tens of kilobits to hundreds of kilobits data rate, but we would expect to extend that into the megabits per second data rate. We've already been testing this on UAVs, and so we know it works. And the idea there would be then to get relatively, nice speed connections. And then we also have another program that's with NASA that's providing a Ka band antenna that will operate on our systems and provide high-speed Ka band mission data connections. And so really we see that we just continue to look at, well, what does the market need, and how can we meet that need, and then how can we build the solution and refine it and then get it available commercially.
By the way, I was just listening to the impressive earnings report, and UAVs was a significant focal point in there. Can you comment a little bit more about that?
Sure. Yeah, we spend most of our time connecting. Well, we spend all of our time connecting things in motion. That's what our connectivity business is principally about. And UAVs are a key part of that. And in particular, either UAVs at very high speed. We've got very wideband channels that do hundreds of megahertz of bandwidth that can do very, very high speeds in Ka band that are on our satellite systems today. They're on orbit and they're in use. And then for very tiny UAVs, we've got very, very small packages that are, less than half a kilogram that can still do megabit per second data rates that are used for very small Group 3 or Group 2 UAVs. And so really, to a large degree, satellite's just a really fast moving platform, right? When you think of it compared to a UAV, it's 17,500 miles an hour, and a UAV is maybe only 100 or 200 miles an hour, but it's still the same problem. Wherever I'm at, I want you to connect me. That's the ask from our customers. And everybody wants it done with as, efficient a swap, size, weight, and power terminal as can be delivered. So that continues to be our focus.
I think there's a big opportunity awaiting the satellite industry and the automotive industry, but maybe we'll save that conversation for another day. But that's really amazing stuff that you're talking about here, Steve. So let's roll back the clock a little bit. What got you into this business in the first place?
Yeah, sure. Yeah, that's a great question, and I ponder it often. But maybe I'll go way back in time. I had this crayon drawing that I made of. I'm going to reveal a bit about my age, but it's from circa 1969. It's a picture of the Apollo capsule coming back. So I was in kindergarten at the time, but I think I was already bit by the bug that early in my life. Right.
I just went to the Johnson Space Center about a month ago, and I was shaking my head. I can't believe we went to the moon, 6, 7 times? Oh my God. Yeah.
And a long time ago, right? And hopefully we'll get back there. But in the modern era, when I finished up my career, my college, I did a degree in electrical engineering in Orlando, Florida at UCF, and got a job with Hughes Space and Communications. And I was supposed to transfer to California, but they said, hey, why don't you stay there and just package satellites up on the space shuttle orbiter and send them into space and get them working. And we got to crawl in the back of the cargo bay of the orbiter and in the cockpit of the orbiter, and we're like, after that though, that's all I've done, rockets and satellites. That's been my whole career, and I love it. I think it's a great, the technology that's there, the ability to solve really hard problems in the sense of even building a program, but then even meeting really unique global needs. It's just I can't think of anything better to do. So I'm very thankful for my career, very blessed in what I've done, and definitely bitten by the bug. I don't think I'd want to do anything else.
I can see it now. Yeah, you had me at space shuttle.
Yeah.
So how can someone interested in the Viasat solution learn more?
Yeah, and I think first step would be just shoot me an email and I'll get them connected, depending on what they need. And so I can share that, Roger, between you and I, we can share that out with whoever might need it. And happy to do that. We'll follow up quickly. And again, we want to solve problems, right? That's our number one focus is, how can we help meet a need that's currently unmet.
Fantastic. Thank you, Steve, for making the time to share your insights with MSUA and the wider satellite community. I want to thank the Mobile Satellite Users Association for hosting these sessions. You can learn more about the MSUA at msua.org. There you can learn how to get our weekly newsletter, which provides updates on everything that's happening in the industry and includes information about upcoming events, some of which, if you're a member, you get a discount for attending. And you can also find out how to become an MSUA member. We look forward to seeing you again next time on MSUA's Game Changers Live. Thank you for joining us today.
Great. Thanks, Roger.